Okay, this is not my most ideal setup, but I wanted to get something done for you guys. So this is working through the notes for lesson 1, 2. I'm going to talk through the problems and do them pretty quickly. I may show a few alternatives for some situations because some of these can be solved in different ways. I can't zoom in on anything, unfortunately, with this current setup that I just hacked together. Um, but I think this should be useful for you guys. Now, to get the most use out of this, what you should be doing is pausing the video um, right after I read through each problem and attempt to do it yourself. If you just watch me do all of the problems, you're not going to get as much out of this. You need to be actively thinking about how the problem's being solved. So the best use of this video is to pause the video as soon as I read through the problem and attempt to do it yourself. And then if you get stuck, then allow the video to continue. Okay, let's say you are planning a group outing with lunch included. The lunch is supposed to cost $3.95 per person, and 24 people sign up. Would $94.80 be a reasonable bill? Explain your answer quantitatively. This is an estimation problem. So the idea here is that you're not actually going to take $3.95 times 24. Um, the idea is you're at a restaurant and you're trying to do this in your head. So what I would recommend is you take the 395 and you round that to 4. Now the 24, that's pretty close to 25. So then if you just take 4 times 25, you get 100. So since 100's just a bit more than $94.80, that's going to make me say, yes, this would be a reasonable bill. Now, this part here, that's a little bit trickier to think of for some people. If you just took that as 4 times 24, that would have also just been completely fine. Okay. Number 2, when shopping for his books this semester, Arden has $400 in financial aid money allocated. He needs 2 paper books for $147 each, an ebook costing $79, and an online homework system access code for $82. Rounding each value to the nearest $10, estimate if Arden's aid will cover his expenses. Okay, so he has $400, so he has 2 books for 147 each, an ebook that's 79, and homework access code for 82. And it says to the nearest 10, so that's going to get rounded to 150. That's going to get rounded to 150. That's going to get rounded to 80. And that's going to get rounded to 80. So they're all rounded to the tens place. I didn't line those up very well, but we can just safely add those. Let's see. So 5 and 5 is 10. 8 and 8 is 16. So that's 26. So, okay, carry the 2. So then I have 2 plus 1 plus 1. So I get $460. Since the 460 is greater than the 400, that means the answer is no. Okay, I forgot to put a box around it. Yes. Okay, let's see if I can flip this to the next page here. Okay. Use the information shown in the pie chart to answer the questions below. When office workers feel they're most productive at work. So I have multiple pie slices here. So I have before office hours, 25%, Last few office hours, 13%. Late morning, early afternoon, 22%. First few office hours, 31%. After office hours, 9%. So question A is, when do the highest percentage of office workers feel they are most productive? So for that question, I'm just looking for the biggest slice. So if it's a pie chart, um, it's visually going to be the biggest one if it's a well-constructed pie chart. So we can see the answer should be first few office hours. What percentage of office workers feel they are not most productive during regular office hours? This one requires a bit more thought and critical thinking as far as how you're reading everything. So they are not most productive during regular office hours. So if you read through these, you can see, okay, first few office hours, those are office hours. Last few office hours, those are office hours. Late morning, early afternoon. If you're assuming normal office hours, then that makes sense that those would be office hours. Now, before office hours, those aren't office hours. After office hours, those aren't office hours. So I want to do the before plus the after. So I have 25% plus 9%. So I get 34% of office workers feel they're not most productive during regular office hours. Okay, so now we're going to take a look at scientific notation, and I'm just going to work the problems. Uh, Make sure you're coming to class to see some more insights on how these work. So write in scientific notation. So I have 32,500. Um, I'm going to take the first non-zero digit coming from the left. I'm going to write that down. I'm going to put a decimal point, and then I'm going to write down all the other significant digits. Now I see the two that shows up, the five shows up. Those trailing zeros, we don't worry about those. And then we're going to multiply by 10 to some power. So now we need to figure out using the original number. So we need to find the decimal point on the 32,500. I don't see one. So I look all the way over here to the right. So I know the decimal point should be right there. And then what I'm going to do is I'm going to count one, two, three, four decimal places to where I just moved it for my scientific notation. So then I put a four up in the exponent for the 10. And then I have to ask myself, is 32,500 a big number in that it's bigger than one? Yeah, it's bigger than one. So then I put a positive exponent. So I just leave it as it is. Now, if it would have been a number smaller than one, so it's got some kind of leading decimal, then it would have been a negative exponent. Okay, so for the next one, we're going to write that number down. So I have 0.000012, and I'm going to write 1.2 times 10, and then we need to figure out by moving the decimal point. 1, 2, 3, 4, 5 places now for the new spot. I'm going to put a 5 there, and then I ask, is it a big number or a small number? And I can see, oh yeah, that's a tiny number. It's smaller than 1, um, so it's going to get a negative exponent. Okay, and that's it. write in standard notation. So I have 1.92 times 10 to the fifth. Okay. Uh, all I'm going to do is I'm going to go backwards. So now if it's a positive exponent, I know I'm going to go in a direction that's going to give me a bigger number. So I'm going to go this way. 1, 2, 3, 4, 5. Now I can see I have some blank spots. Those blank spots get placeholder zeros. Now I don't leave my answer like that because that looks super sloppy. And I want to get a good grade on my test question. So I'm going to rewrite that so my instructor knows exactly what I meant. So I have 192,000. Okay. 9.287 times 10 to the negative 4. Okay. So I'm going to just write down the 9.287. And then I'm going to move the decimal point. Now I can see that's negative, so I'm going to end up with a small number. So I'm going to go in this direction for a small number. So 1, 2, 3, 4. And then there's my new decimal point, and I fill in placeholder zeros. Okay, and then I can put that zero at the start to make it look nice. So I have 0.0009287. And if you leave it like this, where if you leave it like this here, uh, don't do that. That should not be your final answer. You will lose points on a test if you do it that way. Okay. All right. Now we're going to get into some arithmetic with scientific notation. So we're going to try multiplying. So I have 6.1 times 10 to the third times 9 times 10 to the 7. All you have to do is get the regular number parts together and the powers of 10 together. So we're just kind of switching places around here. So I just take the 6.1 times 9. So I get 54.9 times, and then I add the exponent. So I take the 3 plus the 7. So I have 10 to the 10. Now, this is not done because the 54.9 is an improper scientific notation. I need it to be 5.49. Okay. And now, if I'm just moving this over one place, okay, the 54.9 was a big number. It was bigger than 1. So then that's going to ratchet up the power of 10 by 1. Okay. If you have any issues with what I just did there, ask about it in class. Okay. A water desalination plant can produce 2 times 10 to the 6 gallons of water in one day. How many gallons can it produce in 8.6 days? Okay, so I have 2 times 10 to the 6 gallons per day. And then I want to figure out what it does in 8.6 days. Okay, so I can see I'm just going to take 2 times 8.6, and then that's times 10 to the 6. So I'm going to have, let's see, so 19.2 times 10 to the 6. Okay, that's not in proper scientific notation. So I need to move that decimal point one place to the left. So now that was a big number. So that's going to ratchet up the power of 10 by 1. Okay. Next, I have some division. So I have 1.8 times 10 to the negative fourth over 6 times 10 to the negative 7. And again, I just um, separate things a bit. So I have 1.8 over 6 times 10 to the negative fourth over 10 to the negative 7. So this is a little bit trickier. And the 1.8 divided by the 6, that's going to be zero point 0.3. And then what I have to do with the exponents is subtract them. So that's going to be negative 4 minus negative 7. Okay, so I have zero point 0.3 times 10 to the negative 4. And then if I subtract a negative, I add. So zero point 0.3 times 10 to the 3. It's not in proper scientific notation, so I need to move that decimal place over 1 to the right. That's a small number, so I'm going to have 3, and I'm going to ratchet that down. So it's going to be 3 times 10 to the 2 in scientific notation. Okay. Okay, planet A has a mass of 8 times 10 to the 23 kilograms. So planet A has a mass of 8 times 10 to the 23 kilograms. Planet B has a mass of 4 times 10 to the 25th kilograms. Which planet has the larger mass? The planet with the larger mass is how many times larger than the mass of the smaller planet. So A, let's look at these. Oh my goodness. Let's try that again. So 8 times 10 to the 23. B is 4 times 10 to the 25th. Okay. So look at those. Now, uh, if you don't understand what scientific notation's doing, you might mistakenly think, oh, the 8's bigger than the 4, so the answer is A. But if you're looking at scientific notation, you need to look at the power of 10. So the one with the highest power of 10 automatically wins for the biggest. Now, if they had the same power of 10, so if these both said 10 to the 25th, then you would look at the numbers up front and compare those. But if you wrote these out, you would see that B has the most number of digits. So B would win. So it's that bigger power of 10. So planet B is bigger. Okay. And then if we want to compare how many times larger, we're going to divide. So 4 times 10 to the 25th over 8 times 10 to the 23rd. Now this answer, it said write in standard notation. Okay, so the 4 divided by the 8 is going to be 0.5. And then we have 10 to the 25th minus 23. So I have 0.5. And then that's going to be 10 to the 2. And I'm just multiplying this out. So 10 to the 2 is just 100. And half of 100 is 50. Okay, so that's it. Okay, thank you for watching.